Welcome to part 2 of my video, where I build up the theory to explain how to produce anti-gravity force beams. We begin by explaining how large collections of atoms create gravitational fields. We then extend these ideas to explain anti-gravity effects in superconductors. Finally, we look at the next steps to invent anti-gravity. I have some bad news. There'll be a test in tomorrow's class. I notice a number of empty desks at the back of the classroom. I will be very interested in the test answers given by the missing pupils. The problem of understanding how gravity fields are produced in large collections of atoms has puzzled theoretical physicists for decades. Our minds can only think in 3 dimensions. We are incapable of visualizing what happens in a region when time slows down. We now use animations to show how gravity fields are a side effect of inertia. If you've done your homework, you will have watched this animation in part 1 of this series and realized that it already solves the problem. Unfortunately, a large number of pupils phoned in sick for that lesson, which just happened to coincide with a football match. You should understand this video clip, and you will know all about Einstein's equivalence principle. By putting these ideas together, you'll realize that gravity is actually a side effect of inertia. The acceleration force pushing us onto the Earth's surface is causing all the atoms to radiate gravity. We're going to use the standing wave photon model from part 1 to explain mass in atoms. Most of the mass in an atom lies in the quarks inside the protons and neutrons. In addition to the rest mass, there is the relativistic mass increase due to the quarks orbiting around their common center of mass, following the rules of quantum chromodynamics. For simplicity, the gravity animations will show hydrogen atoms with a single proton in the nucleus. They show a single gravity well formed out of the sum of the static and dynamic mass of the quarks. The range of the force of an atom's gravity well is only a few femtometers. It barely extends beyond the size of the nucleus and would not influence neighbouring atoms, which are 5 to 6 orders of magnitude further away. Black box thinkers call this the nuclear strong force. However, when the gravity well is accelerated, it becomes weakly unbalanced in order to provide the inertial force. The unbalance on the trailing edge has to extend over a much greater order of magnitude in order to create the inertial force of the leading edge. The unbalanced force now has the range to very weakly attract neighbouring atoms. This is the secret of how gravity works. We now consider how a volume of hydrogen gas clumps together under the influence of gravity to form a star. The process starts when 2 atoms in free space collide by chance. Coulomb repulsion, due to the electron clouds repelling each other, causes inertial forces on the atom's mass. This is shown white in the animation. The gravity wells unbalance whenever the atom has to accelerate, changing direction. The trailing edge of the gravity well spreads out over a much wider range in order to disperse the inertial force from the leading edge. This is shown red in the animation. The translucent sphere is a marker showing the center of the gravity field. The range of the gravity field has now increased to the point where it can very weakly attract adjacent atoms. With very large numbers of atoms, the effect is strong enough to cause the matter to start to clump together. Once a gravity field begins to form, a runaway process starts. Eventually a point is reached where the atoms are being pushed into each other by their own gravity. The gravity field is now self-sustaining without the need of further collisions. The hydrogen forms a star, and fusion reactions raise the temperature and pressure opposing the pull of gravity. On a planet made of solid material, the atoms are supported against their gravity by the Coulomb repulsion of their outer electrons. The atoms experience a constant acceleration force perpetuating their gravity. Here is the same animation but in 2D. A space-time plane has been added which shows the imbalance effect of the collisions. At the end, the particles are in continuous contact, trapped by the force of their own gravitational field. Newton's gravity equation shows the field dropping off according to a square law. It is proportional to the surface area of a sphere with increasing radius. If we could narrow the angle of spread, we can create anti-gravity force beams. Experiments show that superconductors can create gravity impulses. The superconducting order parameter causes the spin axis in the electrons to align in exactly one direction instead of tumbling randomly. The axis lines up to be 90 degrees to the direction of the supercurrent. The gravity field then becomes highly directional. This is what's shown in the animation. Free acceleration test masses are shown at the right-hand side. One can see how the in-plane distortion causes the masses to move. There are two different types of experiment demonstrating this effect. The simpler experiment applies angular acceleration to a superconducting niobium ring. Accelerometers placed tangential to the ring measure a weak counter-acceleration, despite being completely isolated. Without a superconductor, this effect would be unmeasurable. In low-temperature superconductors, the electrons form Cooper pairs with opposing spin. The magnetism now cancels out and the spin aligns to be orthogonal to the acceleration. No gravity impulses are generated in this experiment because electrons are accelerating in the opposite direction at the other side of the ring. The Pt2B satellite measured the frame dragging due to the Earth's rotation using very sensitive gyroscopes. The result was tiny compared with the above experiment. The niobium superconductor has amplified the effect enormously. In the second type of experiment, electrons are fired in high current pulses into a high temperature superconductor. The results are dramatic. Gravity impulses were observed with directly visible effects. D-wave coupling, only present in high temperature superconductors, has greatly enhanced the effect. In D-wave theory, the electrons move in jerks, while positively charged holes move continuously in the opposite direction. The discontinuous motion of the electrons is the key. A spreadsheet calculation reveals that the momentum of the arriving electrons is considerable. In Poher's experiment, using a 10 kA 4000 volt discharge, the momentum was calculated to be 2.1 kg-meters per second. This easily accounts for the observed recoil. In Pt2B's experiment, the momentum was even higher at 34 kg-meters per second. His experiment used a 1 megavolt discharge. The antiferromagnetic spin waves from the superconductor have aligned the spin axis of the arriving electrons. Both experiments produced visible effects. There was an insulating layer or a gap in the discharge circuit, and the acceleration from the electric field considerably increased the electron's momentum. Poher added insulating layers made of undoped YBCO material to his disk to enhance the impulses. A video of his experiment can be seen on YouTube. He observed that the upward propulsive momentum of his emitter is opposite to the flow of electrons, and the impulse force beam is projected downwards. This is where he placed accelerometers and a water bath. The momentum of the emitter is actually a classical effect. The accelerating electrons are not influenced by the superconductor. However, when they strike it, their counter-momentum is transferred into a gravity impulse. Pt2B used a 1 megavolt pulse generator, a discharge gap and a solenoid to enhance his gravity impulses. His emitter was bi-layered, with a rear layer of normal conductor having the same lattice properties of the superconductor. A small solenoid trapped the magnetic field inside his emitter as it cooled down below its critical temperature. He made several very important observations not seen in any of the other replications. He found that the gravity impulse was proportional to the trapped magnetic field, and his beam was highly directional. He also noticed a strange radiation coming from behind the emitter, shorter in range but which welded metal and plastic together and had a high harmonic content. This turns out to be patterning energy and is a vital clue in understanding how to improve the effect. In later experiments, he measured the velocity using atomic clocks over a 1 kilometer range. The result was astonishing. He measured 64 times the speed of light. He reported that the impulses interfere destructively with a laser beam, blowing the photons away. The above light velocity shows us that the beam is a massless in-plane space-time distortion. Without projection into the fifth dimension, there is no mass associated with the distortion, and nothing to limit its speed. Unfortunately, Pt2B was working inside Russia, and he was refused permission to photograph or video his experiment. There is a serious problem. Heating effects from the high current discharges will quickly bring the superconductor above its critical temperature. The duty cycle will be far too low for continuous thrust. The return current path must always be made through a normal conductor having resistance. If the current is returned through a superconductor, there will always be a counter impulse, cancelling out the effect. A superconducting solenoid cannot produce thrust. Ionizing the atoms in the discharge gap or insulator required to accelerate the electrons will always cause heating effects. Poher had to wait 30 minutes between discharges for the superconductor to cool down. To achieve continuous thrust, we need far greater efficiency. The electron's motion should be in a circular path so that unused kinetic energy can be recovered. One might consider using a particle accelerator such as a cyclotron or a synchrotron. Unfortunately, accelerating electrons emit X-rays, reducing the efficiency and causing dangerous radiation. We must split the problem into two. We need a system stable at very high current and with high kinetic energy to produce the thrust. Plasma is ideal for this. It was observed in the discharge gap of Pt2B's experiment. Poher reported light emission possibly due to plasma inside his emitter. We then need a separate system providing antiferromagnetic order of the electron spin. This is a block of coherent material using laser radiation instead of supercurrent to produce the same ordered motion of charges. It produces exactly the same type of harmonic radiation that Pt2B reported coming out of the back of his emitter. We use a host material with fully or nearly fully occupied D shells to give a stable crystal field and ultra-low phonon loss. Doped YBCO superconductor uses copper 3+ ions and antiferromagnetic fields in the 3D x² - y² orbitals to produce the patterning energy. Any pupil not understanding this incredibly simple topic must read the chapter on D-block chemistry before tomorrow's test. We need to keep the spinning plasma stable and the axis of rotation fixed at the center of the chamber. We can't use magnetic fields due to synchrotron radiation and dangerous X-rays. First, we project a weak gravity field. The field is generated in a similar way to the superconductor gravity force beams. Non-linear effects occur where the beams combine, similar to those seen in high-intensity acoustic vibrations. With acoustics, one cannot exceed the negative pressure of a pure vacuum. With in-plane patterning energy, the limit occurs when the compression exceeds a limit where it contains enough energy to convert into real mass. The patterning field becomes a real gravity field, which collapses the plasma in on itself. Harmful radiation cannot escape. We now offset the rotation axis so that the relativistic mass increase of the rotating ions further enhances the gravity field. We can now increase the kinetic energy of the rotating particles without increasing the energy of the containment field. Since the nuclei are much more heavy, they will project far more powerful force beams, with enough range to wake up the two pupils sleeping at the back of the classroom. Finally, we use fusion reactions to power the rotation of the system. Using hydrogen plasma, kinetic energy from fusion reactions will split the fusing nuclei into two counter-rotating cylinders. The outer cylinder will have the lighter fusion components such as hydrogen, neutrons and deuterium, and the inner will have heavier components such as helium and tritium. The counter-rotation between the cylinders will then add extra kinetic energy into the system. The harmful neutrons will remain safely trapped and put to good use, triggering further fusion reactions. The helium-4 product will separate to the inner region due to its higher mass, and it can be exhausted into the classroom. Everybody will talk in silly high-pitched voices, and the sleeping pupils at the back will finally wake up. Now we will discuss your homework, which you handed in at the beginning of class. You are asked to solve a simple problem. If plasma and magnetic spin are all that's required for anti-gravity, why don't we see anti-gravity in plasma physics experiments? The magnetic fields are enormous and should line up the spins of electrons in the plasma. Any pupil who did not mention antiferromagnetism will be given extra school. The magnetic field is a competing space-time distortion. It is shifted to be unique to the electric charge dimension. Because there is only one dimension for electric charge instead of 3 for space, its coupling into the electrons is far stronger. To create gravity impulses, it must be cancelled out, to force all projections back into the parent space-time field. To get anti-gravity, the magnetic spin must alternate between adjacent electrons. This is done either by Cooper pairing or by antiferromagnetism. The alternating spin must cancel out all bulk magnetic effects. Only then is the energy diverted into a gravity impulse. Now for your homework. Any pupil failing to complete all the exercises by tomorrow's class will be set detention. Your first exercise is to produce a full replication of Pot-Kletnoff's impulse generator. This is not as difficult as it seems. The high voltage source is a Marx generator and is used in lightning test labs. If you can't borrow a Marx generator, you're required to make one this afternoon in school workshop and skip games. You're now required to design a cheaper and safer version for the school physics classroom. It should ideally use an off-the-shelf YBCO levitation disc and produce directly observable impulse effects such as swinging pendulums. A discharge gap should be used to accelerate the electrons using a much lower accelerating voltage, only tens of kilovolts. Consider using a triggered spark gap instead of a thyristor. Any pupil failing to hand in this work will be sent to the headmaster's office. Your next exercise. Evaluate the performance limits of the YBCO discharge system. How high a duty cycle can be achieved without overheating? Any pupil caught nicking liquid nitrogen and pouring it into the toilets back at house will be required to do 100 laps of the sports fields. Finally, investigate unusual effects with laser stimulation of materials with nearly fully occupied d orbitals. For example, nuclear transmutation, excess heat, light and X-ray emissions. Last year, a pupil who skipped his chemistry classes and never heard of the periodic table came up with the idea of lasering sulfur in a high-pressure hydrogen gas cell. The resulting stink bomb explosion of rotten eggs made the chemistry block unusable for 1 week. He was expelled for the rest of term. In my next video, I'll be looking at in-plane space-time distortions and the structure of time. This is the missing link to tie up any loose ends in my anti-gravity theory. I will show that neutrinos, the nuclear weak force, low-energy nuclear reactions, superconductor order parameters and paranormal effects are all caused by the same mechanism.